Alrighty, everybody. After a little bit of a bumpy start, all my fault, I'd like to welcome everybody to number 44. Enough with the JavaScript already. This man you should recognize, because I know you're all here for me, but we're very, very happy to have Nicholas with us today, who is going to reprise his presentation from Velocity. I hope you had a chance to see it. If you didn't, this is going to be an excellent opportunity for you. We are streaming, we are recording, and I will provide copies at the end. So, all of that was taking place. I got to thank all our sponsors, and I have all of the bits ready to go. So, Akamai is a leading cloud platform for helping enterprises provide secure, high-performing user experiences on any device, anywhere, optimized content and media delivery. And Strangeloop. Strangeloop makes websites and enterprise applications faster, automatically. Strangeloop provides advanced front-end optimization, FEO solutions to companies like eBay, PayPal, Visa, and O'Reilly Media. And SOSTA. SOSTA's web and mobile app test automation solution enables developers, QA professionals, and IT operations teams to test with unprecedented speed, scale, and precision. And last but not least, Box, who was very generous in providing both the venue, the food, the beer, the soda, the speaker. Box is reinventing how the world uses business content. And as it turns out, I asked a stupid question, and it turns out our code works for New York's Velocity, because I was like, oh, does the code still work for Velocity? And they're like, yes. So if you didn't go to Velocity here in Santa Clara, but were thinking about going to the one in New York, registration is open. The best price ends today, and that'll knock 20% off of it. So take advantage if you'd like to. If you haven't taken advantage or been lucky enough to win one of our ebooks, we'll get everybody an extra raffle ticket if you didn't get one. They're basically our code, DSUG, makes any O'Reilly ebook the O'Reilly ebook of the day. It basically knocks off half price. They're DRM free, they come with all the extra bits. The catalog is huge, it's awesome. The WPO Foundation, this is something we like to support. It's basically a nonprofit for web performance with the goal to help and fund open source web performance projects and public research into web performance. If you were to, for example, buy this book, are you in this one?
I am.
And he's in this book too. You are actually supporting the WPO Foundation. So actually score yourself a copy. It's got, I think, 22 or some odd basically articles in it. They are excellent reads. I urge you to take advantage of it.
I make no money.
Yeah, all the proceeds go to WPO. So you're actually supporting a good cause. O'Reilly Animals, this was a promise I made to a young lady at OzCon who runs the covers for the O'Reilly project. Coincidentally, most of the animals on the covers are either extinct or endangered. And this is O'Reilly's way of trying to connect people in technology with groups that are doing conservation, like putting GPS collars on lions so that the herdsmen in Africa can move the cattle before the lions come. And then they don't have to put an animal down because it's eating domestic cattle. So things like that, water purification studies, and all kinds of really cool stuff. A great little project. Excellent, check it out. Last but not least, the Twitter bits. We're on Ustream, we're recording, we're streaming, everything's on. And I don't know who's speaking yet for August, so I will announce that soon, but we'll have something, I promise. And announcements, new business, we're gonna keep it totally short. I know Box is hiring. Anybody else? Really, no one is hiring in the entire Bay Area? I know people were asking me if they're front-end developers, so I know they're hiring. Anyway, if you'd like to ask about information, find somebody with a Box t-shirt. They'll be happy to direct you to it. They've got beer and pizza. And that's it, without any further ado. I'm done. You can take over, sir.
So sorry for the delay. As it turns out, my computer was not playing well with the projector. Before getting started, I want to thank Rob, who's just up here showing me how to use a Mac, and also the rest of the Box performance team for setting this up. You guys did an awesome job. Rob even donated his Mac when my laptop wasn't going to work. So stand right there because I don't know how to use this machine. Yeah, and I work for Box. I also do a bunch of writing, so this is like one of the books that you could go and get with your ebook coupon. Some of the other ones, there are a lot of them out there because I pretty much don't do anything on the weekends, and that's the result. You can follow me on Twitter. I would say, hey, stick around afterwards and like ask questions, but we're already running late. So if you don't feel like sticking around afterwards and asking questions, tweet them at me. I'll be happy to answer them later on. So now that we're finally ready to get started, I want to talk to you about something that is very important to me. And that is dark chocolate covered almonds. How many people have had dark chocolate covered almonds before? Are they not awesome? So I discovered these when I was looking for a healthier snack to just keep around the house. So you have almonds, which is protein-ish, and you have dark chocolate, which is like so much better for you than regular chocolate, they say. And so when you combine the two, you get awesome. And so I got these and I brought them home and just kind of had them around for a snack. And one day I had the bright idea that I should take these and put them in a bowl and put them on my living room table. Because that'd be great, right? It's like every time you walk by, you can just like grab some, and people come over and they're just there, and it's kind of nice. And one day I was watching TV at night, a Daily Show or something, and I looked over and I saw the dark chocolate covered almonds. It's like, yeah, why not? Grabbed a few, chowed down, and then looked over, oh, I'll have a couple more. I grabbed a few and chowed down, and then one time I reached over and the bowl was empty. So I had eaten them all, and I ended up with a really bad stomachache. And it's not that dark chocolate covered almonds are bad. They're awesome. But just because they're awesome doesn't mean that you should have a ton, right? And that's what I think has happened to JavaScript, is that we all love it so much. It's so awesome. We just want to use it all the time. But when we use it too much, we end up with a stomachache. And that's what this talk is about. How do we keep our love rational of JavaScript? Now, the fun thing is that people didn't always love JavaScript, if you can believe that. If we go back to 2004, it was very common to see things like this in the forum. This is, why does JavaScript suck so much? And that is January 2004. And it says, granted, I was never that good at Java, but JavaScript drives me nuts, especially because you don't declare what kinds of data types are getting passed in methods. We are trying to write some stuff for a mapping website, and I can't for the life of me figure out how to pass one variable from one method to another. We need to pass the variable region, but I can't figure out how to properly pass it. We declared it as a global, but as soon as the HTML redirects, the JavaScript stops running and the variable disappears. Damn that JavaScript. This was very common around that time. There were a lot of posts about how much JavaScript sucked. What's even better than the question is the answer. It says, maybe you'll get better results when you use a more robust server-side object-orientated language like ASP or PHP. That's much better. Now, in 2005, something interesting happened. Jesse James Garrett wrote this article called Ajax, a new approach to web applications. And that's where the term Ajax came from. And all of a sudden, JavaScript was cool again. because this Ajax thing was coming out. It was awesome, and there was a ton of excitement around this article, a lot of books. I wrote one, other people wrote them. It was Ajax everywhere, and all of a sudden JavaScript was cool. Next most important thing happened in 2006, and that's when jQuery was released, the first version. Now this was important because prior to jQuery being released, people still felt like you had to understand programming languages in order to use JavaScript. Which, that's crazy, I know. But jQuery came around, and all of a sudden it opened up the doors to people who didn't have a computer science background. JavaScript wasn't scary anymore. It kind of looked like CSS, and people kind of understood CSS. So more and more people started tinkering with JavaScript because of jQuery. And you can say what you want about not needing to know programming language to use jQuery. But if not for jQuery, there wouldn't have been that next wave of interest in JavaScript, that next group of people coming up and saying, you know what, this is really important and I need to learn how to do this. Now in 2007, Jeff Atwood of Coding Horror coined Atwood's Law. And that was any application that can be written in JavaScript will eventually be written in JavaScript. And since that time, it seems like we've been trying to make that come true. Right? Every time you turn around, well, we're doing this in JavaScript. We created a PDF renderer in JavaScript. We've created server-side stuff in JavaScript. It's all over the place. Which brings us to today, where we're using JavaScript for absolutely everything. And because we love it so much, we want to spend all of our time working with JavaScript. Ironically, back when I was consulting, I would get called in a lot to places where people were having performance problems and they had traced it back to their JavaScript. I heard this over and over and over again, which is great if you're a consultant and you want business, but it kind of sucks because it made me realize that people were kind of not getting it. And inevitably when I would go in, what I would find is that these places would have over a meg of JavaScript being downloaded initially, and then say, well, why is it so slow? Nicholas, tell us, why is it so slow? Well, you kind of have a ton of JavaScript there, so that's one problem. And so what I tried to teach people is to think about your web app as a bunch of different sections that each had different responsibilities. There's the server, there's your HTML, there's your CSS, and there's your JavaScript. And these actually have some pretty well-defined responsibilities. So on the server, you want to render your HTML, construct your URLs, recalculate some dependencies, and do redirects. The HTML, this is your document structure, and it's your data. It's native functionality, and it's built-in accessibility. You get that for free. CSS, you get your layout, you get your colors, visibility, and even now animations. And so for JavaScript, what you're really left with is handling events, doing Ajax, and then tweaking the UI, right? Making changes as the user interacts with your app. And what we've been doing over time is just taking all of these and cramming them over into JavaScript. And so we have a really unbalanced web application when it looks like this. You're putting all of the responsibilities in one section, and the other ones are being dumbed down so that they're barely doing anything except setting up the JavaScript to do everything. And that doesn't make a lot of sense. Now we know that this is happening because if you look at trends over time, the amount of JavaScript being used per page is only going up. So this data is from the HTTP archive, and it goes back about a year and a half. And you can see that the amount of JavaScript being used on the page has gone up from 152K to about 187K. Now that's gzipped. And we love looking at gzip numbers as performance people because those numbers are small. But your JavaScript files spend only a very short amount of time in their gzipped mode. Right? They're ungzipped on the server, they get gzipped to be transmitted, and then they're ungzipped in the browser. So they're only spending a very little amount of time gzipped, which is why I also like to look at the ungzipped size of that data, because the ungzipped size is the code that you are working with every day. It's the code that you have to maintain. And so if we look at a few large sites, now remember, where we are at right now is about 187K gzipped for JavaScript. And if we look at a few of these top sites, you can say the Yahoo homepage, 196. Any guess as to how much that is ungzipped? And just yell it out. 500. Anything else? Okay, about 500. You don't win anything but good job. How about 256 on YouTube? 1 meg? Any other guesses?
768.
1.5? I don't know, 768. Okay. Not bad. 793. Twitter, 260K. This one should be easy given what we just did. Right, so how much for 260K? Oh, magic. Almost a meg. Facebook, 0.5 meg gzipped. How much in gzipped? 1.5 meg. Right, so clearly the pattern is here. Is that we are using JavaScript more and more and more. And we need to do something to curb that. So these are my cautionary tales, things that you should be aware of, ways to fix them, and why I care about this so much is because my experience over the years of working with web apps, during the development of the project, I see patterns like this. And that is, at the beginning of a project, you start out with a blank slate. You're spending roughly equal amount of time with HTML and CSS and JavaScript, maybe a little bit more on the JavaScript. But as time goes on, the amount of time that you spend on HTML and CSS starts to drop as a percentage of the total amount of work that you're doing. And you end up spending the majority of your time maintaining and working with your JavaScript, which makes sense because that's the thing that's actually executing code. Right? It's stuff that is easy to get wrong. CSS and HTML, you can get wrong, but you can usually figure it out a little bit easier than you can with JavaScript. And so if you know that you're going to be spending most of your maintenance time in the future on JavaScript, it makes sense to try to minimize the amount of JavaScript that you have to maintain. So let's talk about client-side rendering. This is something that came up, I think, fairly recently, the past couple of years. We have all of these really cool tools, handlebars and Jade and underscore and Dust and all kinds of stuff like that. And it's really made people stop and think, you know, I could just do all of my rendering in JavaScript, right? Forget about like creating that HTML on the server. Just do it in JavaScript. It's going to be fine. It's going to be awesome. We're just going to do that. And part of that had to do with Backbone popping up. Now, Backbone is a really interesting library. It marked to me the beginning of this MVW paradigm that people loved. And that's, Backbone wasn't the first that did this MVW thing, but kind of like jQuery, it made it easy for other people to understand. It was simple enough and small enough that people could grok it and just start using it. And because of that, people got more interested in client-side rendering. I don't want to go back to the server. I want to just switch my view and throw some JavaScript at it and have stuff change. Right? And when you follow that trend along, there was this conference last year called Throne of JS, where they proclaimed this on the website. It's no longer good enough to build web apps around full page loads and then progressively enhance them to behave more dynamically. And the point of this conference was to talk about things like Backbone and Meteor and all of these other MVW type frameworks. And so we reached this point where we're all sitting back and kind of marveling at how awesome we are. It's like we have successfully wrested away from the server and HTML and CSS, everything that it's doing, and we can all do it in JavaScript. And doesn't that make us cool? Or awesome? So if you can't read it in the back, it says, "I'm sorry, I can't hear you over the sound of how awesome I am."
What?
Well played, sir, well played. However, there are cracks in the foundation with this approach. Facebook was one of the first to move to this idea of let's load up a page with very little and then start filling in stuff afterwards. And then you would end up periodically with a blank page. This used to happen to me all the time when I was on Facebook doing the words with friends and things. You just go in and you have a blank page and you don't know what to do. So there's actually this entry in their help section about what to do when your home page is blank. And what it actually says up there is if you see an empty white screen when you log into Facebook, try refreshing your page. If the screen is still blank, please make sure that JavaScript is enabled. And so if JavaScript is disabled, you get a blank screen. Well, that kind of sucks. I don't know about you, but like, if I call up my mom and be like, "Oh yeah, Ma, just enable JavaScript." You know what the comment is? "When are you coming here again? So you can do it for me?" Not soon. And so Twitter was also one of these apps that moved to doing client-side rendering. And the interesting thing is they then pulled back away from that. And they wrote a blog post about it entitled "Improving Performance on Twitter.com." And what they said was to improve the Twitter.com experience for everyone, we've been working to take back control of our front-end performance by moving the rendering back to the server. This has allowed us to drop our initial page load times to 1/5 of what they were previously and reduce differences in performance across browsers. Now that's pretty cool, because everybody was saying we can do it faster by pushing everything into JavaScript, and they did that. And then when they moved everything back to the server, that's actually when things got faster. Kind of interesting. Airbnb, similar story. So what they said, our thesis was if we have a JavaScript runtime on the server, we should be able to pull most of this application logic back down to the server in a way that can be shared with the client. Your great new product can run on both sides of the wire, serving up real HTML on first page load, but then kicking off a client-side JavaScript app. That's progressive enhancement. You serve up HTML, and then you serve up the JavaScript that enhances it after the fact. Right? And they went on to say, we relaunched our mobile website using this new stack, replacing the Backbone and Rails stack that it used previously. It looks exactly the same as the app it replaced. However, initial page load feels drastically quicker because we serve up real HTML instead of waiting for the client to download JavaScript before rendering. Plus, it is fully crawlable by search engines. So another big site saying we're moving this stuff back onto the server. It's improving our performance, and it's giving us other benefits as well. So the bottom line is that the server and the browser are actually better at doing this than we are. When we try to do all of this stuff in JavaScript, we are recreating what the server was built to do and what the browser was built to do. We're doing all of that, and we kind of suck at it, which makes sense because they've been doing it a lot longer than we have. And the bottom line here is that progressive enhancement still works. It wasn't a fad that only made sense when we had blogs primarily to deal with. It makes sense for web apps as well. So don't give up on it. We have a lot of people that are moving back to it after foraging off into the forest to find awesomeness, only to come back out and say, you know what, we had it pretty good before. Next cautionary tale, unused JavaScript. So while I was consulting, I would go in, look at these sites that had a meg of JavaScript, and find that 60 to 65% of the code that was there on page load was actually not used by page load time. It was just sitting there waiting to do something. So when they would say, well, how do we start? So you start by moving some of that code away. You don't need that. You can get it off the page. And that's when I would tell them about the 4 JavaScript load times. So these are the different times that you should think about loading JavaScript into your web app. So the first one is in head. That was where we all used to put our JavaScript. The second one is before the closing body tag. That's where most of us probably put most of our JavaScript now. Third is after page load. And the fourth is on demand. And when you look at these and think about when would I want to load certain JavaScript at these points in time, you realize that depending on how people are using your app, you have a lot of options. So I would ask, what are the top 2 to 3 things users do on this page? Based on that, we can figure out when is the appropriate time to load which JavaScript. And that basically means that you need analytics. As with the rest of the performance story, you need to have analytics to figure out what you should be focusing on, what you should optimize. The analytics that you need here, not necessarily numbers about time, but numbers about what users are doing. What are the tendencies when people come to that page? And those you tend to put in the head of the document. A lot of JavaScript libraries that do analytics have to be in the head because they want to start tracking things as quickly as possible. In fact, if you look at Google Analytics setup, there's a section that specifically tells you to put it just before the closing head tag in your HTML. And that's to make sure that it registers the page view even if something happens after that point. And that's usually what you put into the head, is just analytics, maybe some small bootstrapping code, but you don't want to put a lot in. Next is before the closing body tag. And that's any script that's needed by page load. Just basically saying that somebody is going to be using that JavaScript pretty quickly after the page is finished loading. This, I'm hoping, is no surprise to you because it comes straight from Steve Soutter's book, High Performance Websites. It's when we all started putting our code at the bottom. But what's interesting is to look at a page and think about, what do I really need? This is the Amazon page for my book. And granted, I've never worked for Amazon. I've never worked with Amazon. So I'm just making all this stuff up as I go along. But when I go to Amazon, I usually do a search, and then I click through to something, and I will either hit the back button because that wasn't what I want, or I'm going to add it to my cart. That's probably a pretty good candidate to have its JavaScript loaded at the bottom of the body. Because if that's the first thing that most people do, and let's just say I represent most people, then you want the code to make that button work there as quickly as possible. After page load, this is something that people don't take enough advantage of. That is, the entire page is loaded, the initial JavaScript is loaded, but now I want to load additional pieces of JavaScript that I know are going to be needed at some point in time. If we go back to the page, we look at it and say, okay, so what is a secondary thing somebody might do? If the first thing that they would do is add to cart, what's the second thing they would do?
Search.
Maybe it's search. And Amazon search, just like every other search box on the planet, has suggestions that pop in as you start to type. And while you may not need that to be loaded at the bottom of the body, that might be a logical next thing to load, because on a product site, people do search fairly frequently. Let's just say for anything that's needed for the search, that will come in after page load. We'll wait for onload, and then we'll fire off requests to start pulling in that JavaScript. The last one, on demand. This is stuff that you do specifically relating to what the user is doing. Code that maybe is only used by 25% of users, maybe less, or is only used infrequently. You don't need that on the page just hanging around waiting to see if somebody uses it. Go back to the Amazon page. You could make a pretty good case that everything besides add to cart and search can probably be loaded on demand. So this like wish list thing, I never use that. So don't bother loading that JavaScript for me. However, maybe if I move my mouse in that direction, that's when you load the JavaScript in. And Alex Sexton wrote a really nice article called Deploying JavaScript Applications where he talked about doing this. He was working on a site and basically said that the JavaScript for this particular button for write a review isn't loaded until the cursor is within 200 pixels of the button. He created a buffer around that button that whenever the cursor would move into it, would fire off the request and say, load me the JavaScript for this thing. Pretty cool idea, but that's not the only thing that you can do. You can wait until something gets focus. You can wait until the cursor is literally over the area to click on. There's all kinds of different ways that you can do this. The basic idea is that you do it only when the user is signaling some intention to use that functionality. Okay, last section, last cautionary tale is about our beloved JavaScript libraries. They are kind of big, in case you hadn't noticed. We look at some of them. The numbers may surprise you. So jQuery, this is the 1.x, is about 27K gzipped, 90K ungzipped. 2 is supposed to be much smaller because they removed IE-specific functionality. But in reality, it's not all that much smaller. YUI, about the same. Dojo, about the same. Right? So you're actually paying a lot just by including one of these JavaScript libraries on your page initially. And to understand why this is problematic, it helps to think about how libraries develop. So you basically start with no library code at all, because you're writing components. And then you write another component, and you write another component. And at some point you go, you know, I'm repeating myself here. There's code in each of these that's actually the same. And that sucks, because I don't want to repeat myself. I don't want to have this in 12 different places. And at that point, you pull that out, and that's the beginning of your library code. Right? Each of those components no longer need to have that. It becomes a part of the library, so you've actually reduced the amount of code. But then you bring in some more components, and you find a different commonality in there. And so you move that out, and you bundle it up, and you have a library. So you take all of these common pieces, and you move that into the library. What that means is that over time, you see development that looks like this. That is, the percentage of code that you are working on becomes less component code and more library code as you're moving along. You start with no library code, and it starts to get bigger and bigger and bigger. And you start with all component code, and it gets smaller and smaller and smaller as a percentage of the overall code that you're working on. And that also means that the number of components is increasing over time. And whether or not you realize it, JavaScript libraries are actually an economies of scale solution. How many people took economics or statistics in college and learned about economies of scale? Yeah, a few people. And so, a little refresher. Economies of scale exist when the cost per unit produced decreases as the number of units produced increases. That means the first unit produced is really expensive. But as you produce more and more, the cost per unit decreases. It's economies of scale. JavaScript libraries work the same way. That if you're only using one component, you're paying a pretty steep price for that one component. Where you start to get benefit is when you add more components down the road. When you get to 5, 6, 10, 15, that's when you start to see benefits. And so you really don't ever want to do this, right? Load a bunch of different JavaScript libraries onto the same page, because they have common core pieces, and now you're duplicating functionality. Not only that, you are taking that cost of first component that is really expensive, and you're doing it multiple times. So I did actually go in to work with a client and found they had jQuery and YUI on the page. YUI was on the page only because they wanted one component. The cost of that one component was about $300K for one component. It's way too high of a cost. Let's talk about one of my favorite components, which is tabs. All right, I'm going to take my life in my hands here. I'm going to try to switch to a browser. Hold on. Oh, no round of applause necessary. That's fine. So, no, please, stop. So this is what tabs look like, right? Right? Very impressive. I know. That's all that it is. It's just tabs, right? You click on something, it shows something else. This is not rocket science. There are much harder problems in the world than this to solve. For instance, getting my PC to work with this projector. That's a different story. So let's talk about the cost of tabs for that very simple interaction. jQuery. How much do you think ungzipped it costs you to get the jQuery UI tabs? Just yell it out as if you're not stuffed with pizza. 30. 100, did somebody say 190? Gzipped? Yes. Anybody else? No, just tell us what it is, damn it. Okay. So gzipped is 63K. And since we are all really good at gzip math now, how much is that ungzipped?
115.
115. Not bad. 120K. 120K for tabs. Okay, let's go YUI, gzipped, 30. Ungzipped, 95. Both cases, 100K. For tabs. Well, you may be thinking, well, tabs might be really more complicated than we think it is. So maybe you actually need all of that code, right? Because it's hard, and that's why these libraries exist. So this last row here is me. I don't know if you can tell that. Can you tell that? That's me in the corner. So how much was my gzipped solution? 5, 10, 1. What? 1.9K. Ungzipped. How much?
1.9K.
5. That would be a neat trick. 5K. 5K. That's like 95% smaller than the other ones, I think. Math guy, is that like 95%? Okay. So you may be asking yourself, how on earth did he do that? Is he some kind of Superman? I whipped out Photoshop for that. Yeah, it should be. No, it's really very simple. And step one is include the HTML on the page itself. Progressive enhancement. Woo. There we go, HTML. No JS yet, it's just on there. Step two, store some UI state on the DOM. Now this is something that I don't see enough of. A lot of times, these JavaScript libraries are tweaking the DOM to do certain things, and then there's like some object over here that is also maintaining state, and then they have to do synchronization between those two. And that sucks. So you know what? This state is actually affecting the DOM. Just stick it right in the DOM. Right? So right there I have a class that says a selected tab, and then I have a class that says that that's a selected panel. Just in the DOM, there's no JavaScript bootstrapping to this whatsoever. It's just there, because I can look at the DOM and find that class and say, oh, okay, I know what I'm supposed to be doing now. Step three, sprinkle in some JavaScript. That's all I put at the bottom of the page. Just this little init call, and it goes through the DOM and figures out what to do correctly. And it doesn't matter if I have 1 tab, or 2, or 3, or 4, or like 20 instances. I don't need to do anything else except for this. Because all of the information that I need is in the DOM already. I just go look for it. Yeah, so this is how you would do it in other libraries, saying new tab view something or other, or $.tabs. Don't have to do any of that. You just add more HTML whenever you want to create more tabs. And then I go in and I add a few extra things into the DOM just to make life a little bit more easier for the JavaScript. More easier, that's awesome English. And people have said to me before, well, sure, it's really small, but part of the reason that we use these libraries is because of what we get baked in. We get accessibility baked into this. And your thing probably doesn't have accessibility. And that's totally wrong. So what I actually do have here is keyboard controls built in. And it has all of the ARIA stuff and all of the focus controls that you need. So all of it is there in 5K ungzipped. And that's what it looks like. The ARIA roles, tab index, ARIA labeled by, ARIA hidden, all of that stuff to give a really good accessible tab view experience, all in 5K. So what does that 5K actually do? First, it looks for tab views by looking for this data attribute, data-NUI-type. Then it reads the UI state right out of the DOM. Third, it annotates the DOM with additional information. So whatever are the things that are related to that tab view, just throws it in there because there's no other place to store that information. That there's not an object that mirrors what's going on in the DOM. That it uses event delegation to watch for what the user is doing. So I don't need to do on-click for every single tab view. I just listen at the document level and then look at the target that comes in and figure out what to do. To affect the UI, I just swap CSS classes. That's it. And I put all of this code up on GitHub so you can go and play with it. This is not a new library. Do not go out and tweet or tell your friends that Nicholas Zakas made a new library and you should all go start using it. That is not what this is. This is a demo that I put together for the purposes of this talk to show you how this technique works. So please go and look at the code for that. And don't start filing bugs against it and be like, I tried to use this in my app and it's shitty. Sorry, it's a demo, that's what you get. Okay, so in conclusion, I like to think about JavaScript along a couple of axes. And that is, how much value is that providing versus how many bytes do I need to get that value. So if I have very few bytes and it's providing a little bit of value, then you're in this lower corner here. Right? That's okay, it's fine. And if you add a ton of bytes for a ton of value, that might be like a rich text editor, that's also okay. What you don't want to do is end up in this lower right corner, which is where you're adding a ton of bytes and getting very little value out of it. Okay? That sucks. And of course, if you can end up in the upper left, well, that is awesome. To have a well-balanced web application, you want your responsibilities to be divided up like this. Let the server do what it's good at. Let HTML do what it's good at. Let CSS do what it's good at. And then when you can't do it with the server HTML and CSS, then do it in JavaScript. Remember the 4 JavaScript load times. In the head for analytics and small bootstrapping stuff, before closing body, does anything needed by page load should also be as small as possible. After page load, for anything needed soon after, and on demand, if you want to wait for what the user does to figure out what to load. And keep in mind that JavaScript libraries are an economies of scale solution. You pay a lot for that first component that you put on the page. So it really only makes sense if you're using a lot of components. That's when you get the benefit. If you're using 1 or 2, you may want to see if you could just do that yourself. Because JavaScript libraries are big. You're paying a severe price to get that first component on the page. So decide if it's really worth it for you. And don't treat JavaScript like I treat dark chocolate covered almonds. Don't use so much of it that you end up with a stomachache. Thanks. And so these slides are up on SlideShare if you want to go check them out. It's my Twitter, my blog. If you want to hang around and ask questions, you can do that. If not, feel free to tweet them. And that's it. Go ahead, you have to yell.
Okay, you said let the server do it. And do what? And give us an example.
Let the server do it. So the server is really good at putting together pages and delivering HTML to the client. Let it do that. Don't send down nothing and then have JavaScript go and start to fill in pieces. Other things that it's really good at, redirection. I hate JavaScript redirects. It's a really bad idea. Why do I hate them? One, because you're passing a cost onto the user, both in terms of time and in terms of bytes. You can do a redirect a lot faster by doing a simple htaccess redirect than if you force a user to download the page and then embed in it, go to someplace else and actually redirect them. Make sense? Cool. Other questions? Yep.
So how do you load JavaScript after the page is loaded?
How do you know?
What's the actual implementation for doing that?
Oh, how do you load JavaScript after the page is already loaded? So you create a script node using JavaScript. Say document.create element script, and then you set script.source equal to whatever you want. And then you append that script node to the DOM. And then it will go out and download it for you. And in most browsers, there's an onload event for it. And in older versions of IE, there's an onReady state change event that can tell you when it's finished loading. Yep. Yes, you.
I have two questions. I'll start with one. Follow up with what we just talked about.
Excellent.
If I order rightly page is completely loaded. So through JavaScript and injecting the script tag, or just putting it under the other JavaScript, they actually, it's already, so the page is already initialized by the previous one, and there is one at the bottom that is just adding functionality. But the page is already ready, so it's already...
What is the difference between including a script tag at the bottom of the page and loading something after page load? Is that what you're...
Yes, I mean, you need some JavaScript to make sure the page work. But let's say I have 3 tags and I will put tags at the end of the JavaScript. One could have the first one could be the one to make all the page work, and the other one could be the extra one. So what is the difference between this technique and the one that is actually doing the AJAX request, not the AJAX request, getting the script tag after?
Okay, so I'm going to try to summarize that. Let's say it's, I think that it's, just so everybody else can hear, and correct me if I'm wrong. So I think that the question is there a difference between including the JavaScript in the HTML versus dynamically loading it afterwards? Is that right, or is that wrong?
As 2 separate JavaScript elements.
2 separate JavaScript files?
Yeah, so like one is the JavaScript you need to render the page, and one is all the other things.
All the other stuff.
Yeah, like if you, I'm sorry to make it more complicated than what it is. But like, let's say normally the right way, you load the old JavaScript, the only one that you need at the bottom of the body, and then later you do the defer loading of the JavaScript. So instead of doing this, if I add another script tag below the other JavaScript that we will put there anyway, what is the difference?
Okay, I think that we are actually talking about the same thing. So I'm just going to go ahead and answer it, and we'll see if that plays out. When you put a script tag in the HTML itself, the browser spinner, busy thing, I don't know what is the appropriate throbber. Is that what it's called? Sounds more interesting than anything else. Any requests that are being fired off by the script tag have to come back before that will stop. So before the user gets an indication that your page is loaded, that code needs to come in. When you do it after page load, the throbber has already stopped. And so you're not visually affecting the user experience at that point. Did that answer the question? All right, we got it. Awesome. Yes?
Do most modern browsers allow you to put any arbitrary attributes in the tag?
I'm sorry, can you say that again?
Do most modern browsers allow you to put any arbitrary attribute into any tag, so I can use the store state?
Yeah, the question was, do browsers actually let you go in and add those extra attributes? It's actually always been possible to do that. You've been able to do it pretty much since, I would say, IE 5. You can pretty much add in whatever you want. The problem is that you don't know if an official attribute of that same name is going to come out with it, which is why HTML5 introduced the data dash convention. So you can be assured that when you add something with data dash, that there is never going to be an official thing that has data dash, so you don't have to worry about clashes anymore.
How would you address I get the sense part of the attractiveness of just having all your rendering logic be in JavaScript is so you can write a JavaScript API or JavaScript web service and not have to have both a JavaScript web service for AJAX and another one for client-side rendering for HTML. From my experience building web applications, it's really attractive just to have one JSON web service and build all your security around that rather than have a JSON service and an internal API or service that's used for server-side HTML generation. Any thoughts on that?
So the question was, or I think rather the statement was, I think that for JavaScript, people want to put everything into JavaScript so they can have nice JavaScript APIs that they can share and deploy. Is that about a good summation?
And not have to worry about another set of API for server-side rendering. So you both have server-side rendering and client-side rendering code.
Yeah, and not have to worry about having a second set of APIs for server-side rendering. So I think in a lot of cases, it's not necessarily the best idea. Because again, like JavaScript tends to be the more difficult part of the stack to work with. And whenever you can push off stuff to the server, you actually save yourself headaches. And there's nothing that says that you can't create a JavaScript API that actually does go and hit a server, right, and return something in an iframe, which a lot of times people do when they want to control more than just like the JavaScripty part of it. I think that my position still remains the same, is that the more that you put into JavaScript, the more pain you're going to have later on. And if you can figure out a way to minimize it, I think you'll be happier in the long run. Which also isn't to say that you can't create an API that can be used both by server and by JavaScript. Because in theory, if you have a web API that is returning JSON, then anybody can consume that. And so you actually are just giving people more choice than anything else. Does that make sense? We can always talk about it tomorrow, too. I work with that guy. Yep.
You mentioned storing state in a DOM. Is it not radically more expensive to use these DOM APIs to get at data that you're going to be doing a lot of processing on versus actually storing a model in the server? Is there not a performance concern with that?
So the question was, if you're storing state in the DOM, aren't you incurring a performance penalty versus just using a regular JavaScript object? Calling get attribute is not expensive. What gets expensive in the DOM is when you start moving things around. And that's usually only expensive if you're changing what's being displayed. Because what starts to take time is that you're recalculating things. But when you have a reference to an element, and you say get attribute, that's pretty fast. I never worry about the overhead of that. Well, any other questions? Yep. So you have to yell from there.
I'm wondering if the guidance applies to mobile, because you have much more latency, so is it worth it to combine all the JavaScript in one file? Maybe not in one file, but is it worth it to adopt the strategy to push more JavaScript combined as opposed to prefer low latency as round trip latency, latency higher or all that? What are your thoughts on that?
Okay, the question was, how does this apply to mobile because you're dealing with more latency? Maybe you don't want to download more stuff later on. You just want to get it all through. I actually still kind of do the same thing on mobile. The part that I usually leave off is the on-demand stuff. But you still want people to be able to come in and do whatever is that first thing that everybody does really quickly. So you want to make sure that the JavaScript for that gets down as quickly as possible. I still maintain that once you've handled the first two things that people usually do, you have the opportunity to wait. And you may not want to wait for an on-demand opportunity with mobile, but you may just want to wait until later in the page cycle, even after page load, and download additional stuff. So I think it still applies. Yep.
So web is evolved. It started out initially as hyperlink static documents, then people realized they could generate HTML on the fly, and then layer on more JavaScript. I think where it's going to go eventually is going to be a fully distributed communication platform. Not there yet. We need bi-directional communication from client to server. And where does that go with this performance? We're going to take a holistic view. Like there's the DOM manager, there's a guy with a TCP connection to the back end, there's got some execution engineers, they're all putting that together. And how all that's being used is in self-chain. So, it's a moving target, right? So where do you see that going?
Yeah. I don't know how to summarize that accurately.
Hopefully I said it loud enough for everybody to hear.
Ready to hear that? So So I think that the overall question is maybe like, the web has been changing from static to dynamic. Where's it going next, and how does this fit into it? Is that close enough? Okay. I have no idea. To me, honestly, it seems like there is all of the possibility in the world, and we just need to go out and figure out the best way to use the internet now. I don't know. I think there's all kinds of awesome opportunities, and I'm still, in my own mind, unsure of like, are we going to want like Photoshop in the browser? I don't know. Do we actually want like full-fledged Microsoft Office in the browser? I have no idea. Like, maybe in some cases it's not appropriate for some of these things. I just don't know. I'm sorry, I know you're looking for some like wickedly insightful answer, and I don't have one to offer. Any other questions that people want to? Yep. Is this your second question? Okay.
It's a comment follow-up. What do you think about? In my experience, the size of the JavaScript can till a certain point. I mean, of course, if it's getting too big, it's too much. Of course, what in my experience, what is making a lot of difference is how much memory the JavaScript is going to use. Because I've seen like a relatively small JavaScript that are having both memory leak and creating a lot of objects that we need to be created. And I've seen big JavaScript that they keep it expressly quick, deciding the loading times. If you think about it, nowadays a lot of stuff is on SDN, like Google CDN. So what do you think about that?
So what do I think about JavaScript performance as also being related to memory?
What is the balance between the two? Like keeping the JavaScript small, but also the memory footprint.
Okay, so
it's more important.
Oh, which is more important, keeping the JavaScript small or the memory small? Yes. It's both important, and they're related too. Right? Like, it's really hard, but not impossible, to use a ton of memory with very little JavaScript. So the less JavaScript you have, the lower your memory usage is. Part of why I like putting UI state in the DOM is that you are saving memory versus having another object that's managing that state someplace else. Right? So what I usually look out for is duplication of where data is being stored. I love the DOM because it's basically a data structure that already exists for you. So the more that you can take advantage of that and not create something that needs to mirror all of the data that's in the DOM, then the less memory you use as well. So I think like number one, it's like you shrink the amount of JavaScript you have, then you'll end up seeing your memory shrink down, and then you go back and see, okay, where am I duplicating effort here? Like, where can I take advantage of what's already in the browser versus stuff that I'm creating myself? Okay, well, last question, because I need to eat dinner.
In reference to the penalty for loading JavaScript libraries, if you say loaded jQuery off the Google CDN, how does that affect your view of the performance hit you're taking for loading libraries?
The performance hit for taking a library is the same no matter where you load it from. The only difference is that you're saving some bandwidth. Maybe you're saving a few cents on your bandwidth bill each month. But the thing is that you are still getting that 100K onto your page. So that's the penalty that you're paying in terms of performance. Well, thanks. Feel free to tweet other questions at me after I eat dinner tonight. I will happily go on and answer the rest of them. Well, thanks.